frequency tables. A frequency table is a really good way of collecting data or displaying data when we've collected it. So this is the answers to the question, how many siblings do you have, that one of my classes answered. When we make a frequency table, the different possible answers, ranging from the lowest answer that was given to the highest answer that was given, go in the score column. It's the first column, and so answers go here. Now, from the lowest to the highest, we could have an answer of 1, 2, 3, 4, 5, or 6. You'll notice that this class didn't actually have anyone with 5 siblings, but we still list all the possibilities between our lowest and our highest. The tally column is here, and this is a really good place to record your data when you get it. So if you set this up and wandered around asking people, you could just put a mark. So when someone said, oh, I don't have any siblings, a mark of 1. Sometimes also your data isn't in order, and that really helps. So the tallies get done with a set of 4, and then every 5th one is a strike through, so it's very easy to count. And there were 13 people there. 10 people answered that they had 2 siblings, and 1, 1, and 1. So that is our tally column, just little stripes. And then you add up your tally to work out the frequency of that answer. One person said that they had no siblings. 13 people said that they had 1 sibling. 10 people said that they had 2 siblings. So these are the answers. These are just how many times I got that answer. If you add up the entire frequency column, it's 14, 24, 25, 26, 27, what that tells you is the number of people who answered the question. So you can see immediately what our mode is. The mode is the highest, the answer with the highest frequency. So the mode, now the mode does not equal 13, the mode equals 1, because 1 was given 13 times. To get the average, a little bit harder. We can learn to get the median, and to get the range, of course, is the highest score minus the lowest score, so the range would be 6. Now what we can also do is, when the data is a lot more spread out, it's got a bigger range, I don't want to list every possible score from 24 to 46, including the half. That would be a very, very big table, and it wouldn't help me much at all. What we can do instead is do a grouped frequency table, and you're aiming for sort of about 4 to 7 different rows. So I know I've probably got about 25 scores in here. So to make it easy, you can start on a little bit lower if you want, or you can start right on the 24. And I'm going to say even groups. If I did groups of 10, 20s, 30s, and 40s, I'd only have 3 rows. That's not really big enough. So maybe groups of 5. 20 up to, now 20, 21, 22, 23, 24, oh, you can't see me counting there. 20, 21, 22, 23, 24. 24 would give me 5 scores, and then 25 25, 26, 27, 28, 29. Up to 29 would give me another 5 scores. Then 30 up to... Now, the reason I'm not filling this in is what if I say up to 24 and someone got 24 and a half? That's not very helpful at all. So some tables say up to less than 25, and they do that with less than 25, like that. So the first one, 20, up to less than 25. Some tables just do 25 up to, and then leave that bit blank. And then 30 up to, and leave that blank. So we might find some different ways that people have done these tables. If we could only have whole number scores, then 20 to 24, 25 to 29, that would be okay. So you'll see how these go in a pattern. That helps you know that you've done the right things. I've gone up to 40. Do I need to go above? Yes, 45. Oh, and I need to go one more. No, I don't, because 45 up to 49. So I can put that last one in there. So there's all sorts of options. We can just leave it up to, and it says up to almost 25. We can do up to less than 25. Up to us. Now a tally. See, this is really useful. 20 up to 25, I've only got 1. 28 and 29 are between 25 and 30. 34 in here. See, this is where it's quite useful to have up to less than 25. Whoops. Less than 30. So it's up to you. If you prefer to have that in there, do that. So this is 30 to 34, or 34 and a half if it was there. Now 35 up to less than 40. 1, 2, 3, 4 of them. 40 up to less than 45. Whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 45 up to less than 49. 1, 2, 3, 4, 5, 6. And then we can fill in our frequency. And that can really help us see where most of the class was. Most of the class here was in the 40 to 50 range. Really good work. The modal class, we can't say mode because it's a modal group. The highest frequency is the group between 40 to less than, oops, not equal to, 45. So this is the modal class. This is a group or a class, each of these groups here, and this is the group that had the most in it. So a grouped frequency table, it's a good idea to be able to read it, and definitely to be able to put one together if we've got very spread out data. Now I do keep talking about number answers and word answers. Numerical data is any time I get a number answer that can be counted or measured. So the first two, oops, a number answer that can be counted or measured. So those two I just did were number answers. When I asked how many siblings have you got, I got a number answer. When I counted up your test marks and measured them, I got a number answer. We can also have categorical data. And it's not a number, So when I ask, for example, how did you get to school this morning? You don't say 1, you say by car. Any answer that's not a number is categorical. There are some numbers that actually can't be counted or measured, like postcodes, or a scale of 1 to 10. If I say a scale of 1 to 10, where 1 is I hate it and 10 is I love it, these are just numbers standing in for non-number answers. I hate it and I love it. So we can find the mean, median, mode, and range of numerical data, but I can only find the mode of categorical data because I can't add them up. So here's an option for doing a frequency table for categorical data, the class transport method. Bus, or walk, bike, etc. Put the 4 different options in here, do a tally from the class data, work out the frequency and the total. I think you can do that one on your own.